Welcome to another episode of Math Snacks with Miss Lovely and Miss Wonderful. Today's episode is where does equations come from? What do you mean by that, Miss Lovely? Where does an equation come from? It comes from the back of the book.
No.
Sure, I know them all. I've seen them all the time. Look, you see things like 4x plus 3 equals 27.
Right. You're right. That would be a great example.
I see that in my textbook all the time.
That's a great example of an equation. But guess what? That 4 stand for something, and that x, the unknown, is also something important that we need to know about and where they come from.
Usually it's just you got to figure out what x is.
That's true.
Okay.
That's what we're trying to do is try to figure out what x is. But that 4 and that 3 have always come from somewhere.
Okay, so you're going to help me figure out where an equation comes from today.
Right. We're gonna use a problem that we like called the border problem, and I have a challenge for you. Okay, there's the picture, and we're gonna pretend that that's either since I like to swim in the summer, that's going to be the border of my swimming pool, and those blue tiles are going to be around the outside of the pool.
Okay.
Okay. Now, without counting those, I want you to figure out how many blue tiles are there. And I'm just going to give you one little hint. This is a 10 by 10 grid. Okay?
Okay.
So if that's a 10 on this side by 10 on this side, how many tiles do you think are all the way around my swimming pool so that I don't have to count them every time?
I know 40.
40. Okay?
I think it's 40
How
because
did
10,
you...
10, 10, and 10 makes 40.
Okay, and that is a very common response. 40 because you say that there are 10 and 10 and 10 and 10. I would like for everybody else to figure out whether you are correct or incorrect, and we're going to pause the tape.
Okay. Okay, we're back. And they're going to prove if I'm wrong or right.
Well, actually, I think you have thought a little bit more about it, and maybe you can tell us whether you're wrong or right.
Well, I think my first answer, 40, I wasn't thinking so straight on that one, Miss Lovely.
Well, why not, Miss Wonderful?
Well, because after thinking about it a little bit further, can I do it with a different one so I can show you what I'm marking?
Sure.
Here's another 10 by 10 grid, and I started thinking about, there's not really 10 on each side.
Why aren't there 10 on each side? Because I told you it was a 10 by 10 grid.
Well, because they share these little squares here.
Oh, the corners.
The corners get shared.
Okay.
So I decided because it's not really 10 anymore, there's actually 8 and 8 and 8 and 8 plus 4 more.
Okay, so you're saying that you think that this numerically would be a better representation of that, either adding 8 4 times or multiplying 8 times 4 and then adding the 4 corners. Okay, so you have, we're going to start to think about that equation business that we talked about earlier. There was a number and there's another number, and guess what? Eventually we're going to get there.
Okay.
You want to see a way that I've seen this shown before?
Let me get you your own sheet of paper, though.
Okay.
Okay.
I would go back to something that you said to begin with, that there were 10 and then another 10. But then guess what? Let me have a different color because I have a different number. On the sides now we only have 8 and 8. So my numeric expression would be 10 plus 10 plus 8 plus 8.
Cool.
Another way to show it. And guess what? It's still going to give us the same answer because we didn't really say what your total answer was, did we?
No, but I know that 8, pull mine back up, 8 times 4 is 32, plus 4 more is 36.
And mine would be 20 and 16, which is also 36. It was just a different way of showing it. I bet you there are some other ways too.
Well, actually, I saw another way. As you were showing that 10 and 10 and 8 and 8, I saw something else.
What did you see?
I saw there's 9 along here.
All right.
Then there's 9 along here. And 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 9 along there. And then there's 9 along here. And that leaves 9 along here. So there's actually 9 4 times.
Right there. And guess what? 9 times 4 is?
36.
36 as well.
Or because of repeated addition,
it could be
9 plus 9 plus 9. So there's another option.
Okay, I know another one. Can you believe there are this many ways to show it?
So far.
I actually need 3 colors of pen this time.
Okay.
Because I can start on the top with a 10.
10.
And then I'm going to change, because I have a different number, a 9, and then a 9, and then the last side
10,
would be
9, 9,
an
8.
10 plus 9 plus 9 plus 8. A whole nother way to find the number of border squares.
And does it work? 10 plus 9
is 19.
Plus 9 more
is 28.
Plus 8
is 36.
Okay.
It works. It's perfect so far.
I just thought of another way, but I want to go back to the one with the border, with the blue.
Okay.
For a reason.
Okay.
Because I thought about something you said about your swimming pool.
Uh-huh.
If that was a swimming pool. Which swimming pools sound really cool this time of the year. Yay, swimming pools. But I thought about it this way. You said this was a 10 by 10.
Right.
So if I would subtract out what's in the middle.
Right.
I would have how many tiles are around it.
That's correct.
So if I think of it this way, as the whole thing is a 10 by 10, which is going to equal 100, and the inside, because we're taking 2 off of each end, is really an 8 by 8.
Right.
So there's really 64. So if I just subtract what's inside out of that, that'll tell me how many total there are.
And guess what? When you do that subtraction, you get 36 as well.
10 times 10 is 100 minus
64
equals 36.
Perfect.
Cool.
You know what? There's one more way to do this.
Okay.
And if you will, I just need, well, actually, let's go back to your first assumption. Your very first one where you thought it was going to be 40.
Yeah, I was thinking straight.
Here's what you could have done. If you had done a 10, a 10, a 10, oops, I kind of slid here, a 10 and a 10, and then realized that I've touched twice on each of the corners.
You counted those, though, twice.
I've counted them twice, but if I take 10 times 4 and then subtract out the 4 that I've counted twice, I've got the last way to show how many border squares we have.
Wow, that is so cool. And they all give us the same answer.
6 different ways to do the exact same thing.
Oh, okay, I like this. I'm just thinking about now, the next step would for us to think about is, that works for a 10 by 10, but how about for any size of a square? That's
how we get to the equation. We prove that we can do this over and over for any size square, and then what we try to do is find out what it would be like for no matter how big a pool we have or how small a pool we have. We can always figure out the number of tiles, and that's where an equation comes from.
But let me guess, that's a math snack for another day.
I think that is.
Okay. Well, thank you so much. It's starting to make sense with me. But,
Good.
you know, when you start talking swimming pools, then I really start, that makes a lot more sense to me. It also helped me to see it visually.
I think visual or a concrete representation always is a great place to start.
Okay. Well, thank you, Miss Glovely,
You're welcome.
Sharing your expertise with me another day.
We'll finish this up another time.
Okay. Join us for another episode of Math Snack when we do part 2 of the border problem. Bye.
Bye.
If you're interested in more information about Math Snacks, or you'd like to bring Miss Glovely or Miss Wonderful to your classroom, call Miss Glovely, Renee Smith, at 620-663-9566.